In this next example, I've got an a value of -1, and that tells me that it's an upside down problem. Step 2, find the y-intercept, is quite straightforward. Let x equal 0. So here we just have 1 squared, which is 1, multiplied by negative. So we've got -1 plus 4, which is 3. So I can put that straight onto my graph. Now, rather than look for x-intercepts, let's do that easy step. Because we're in vertex form, we can read the vertex straight off. We need to say x minus something. Now here we have x minus -1, because that's how you'll get a +1. We've taken away -1. So my vertex will be at -1, 4. Remembering that our formula says x minus something, and we think about what we've subtracted, plus whatever this number here is will be that y value of the vertex. So -1, 4 is here, and I can label that point. Now I've got a lot of the things that I need because I have that shape, so I know that this is my top turning point and it's coming down like this. But before I draw it up, it'd be nice to know those x-intercepts. Now when we find x-intercepts, we let y equal 0. Same thing here. Let y equal 0. So we have this first line, which is the line that we sometimes leave out. Sometimes we'll start by doing the next step. Let's subtract 4 from both sides. Or we could add all of that to both sides, either way. And we're going to get this. Next step, we could divide both sides, or multiply both sides for that matter, by -1. And that will get rid of both negatives. And in fact, some people might have written that line next anyway, because they might have added this whole section to both sides, and that would have moved it over here as a positive. Take the square root of both sides, so that instead of x plus 1 squared, we'll just have x plus 1. But don't forget that when we consider something squared equaling 4, we know we need plus and minus the square root of 4. Now the square root of 4 is actually 2, so here you could just put 2 in, but think this through because many of your answers will give you surds here, and that's perfectly okay. Now to get x on its own, we just subtract 1 from both sides. So we end up with plus or minus 2 minus 1. So if it's 2 minus 1, it'll be 1. And if it's -2 minus 1, it'll be -3. So now we've got our intercepts, and we can go ahead and draw the rest of our graph, and we're finished. Now I think that this working is probably the easiest, most straightforward way to do it, but there's always more than one way to do something. So if you've already looked at questions like this and you've learnt a different method, one other method could be spotting the difference of 2 squares here. So if I'd rearranged this line so that it said 4 first, and I had 4 minus something like that, then it would be perfectly acceptable, although I think not quite as easy, to say I've got the difference of 2 squares here. So I've got 2 plus and minus this, x plus 1 and x minus 1. That tidies up so that we get 3 plus x here, and we get, what's that, 1 minus x there. And we can easily see the solutions to that now are still -3 and 1. Whichever method you prefer. If you love to complete the square, go ahead and do it. That other method of getting numbers on both sides and taking the square root is probably simpler. Just a word of caution. Sometimes you'll forget maybe to do the plus and minus. So make sure with that other method that you're doing that every time. Now you can't use the difference of 2 squares if you don't have the difference of 2 squares. As soon as you've got 2 parts here that are both positive, or 2 things that are added together, you don't have the difference of 2 squares. But don't forget that if you're solving one like this, the other method of moving the constant onto the other side and saying, well, this is -2, equaling all that, that method won't work either, because clearly anything squared has to be positive, and now we've got something squared and being negative. So don't forget that in this situation, all it's telling you is that there aren't any x-intercepts. And that happens every time we've got an upright parabola that sits above the x-axis or an upside down one that sits below. And the other situation that you'll see sometimes is that when it's arranged in vertex form, there actually is no k, or virtually k is 0. So in that situation, when you go to find your x-intercepts by letting y equal 0, straight away you are here. And if you take the square root of both sides, you can see that there's only going to be one solution, because the square root of 0 is just 0. There's no point saying plus or minus 0. So you're going to end up then with just one answer. And this is completely normal because there are quite a lot of parabolas that are upright but only just touch that x-intercept in one place, or if they're upside down, they could do the same thing and just touch it. Now, one of the names that you might have seen in your textbook, or that you might come across soon, is the word roots. Now, when we find x-intercepts, it's often known as finding the roots of the parabola or the roots of the quadratic function. So in this case where we have one that just touches the x-axis, we call this a double root. And one more example so we really get the hang of it. Again, we start by saying which way up is this one? Well, it's upright. And what is the y-intercept? Sub in x equals 1, and we have 1 squared is 1, times 3 is 3, minus 1 is 2. Put that straight on. Now we can read the vertex straight off here, being careful to make sure we're saying x minus -1. And at the end here we've got -1. So -1, that's going to be here. And we know it's upright, so I'll put my label down where it will be out of the way below it. So I can see here that I'm going to have a shape roughly like this. Now to find our x-intercepts, let's let y equal 0. So we have this. Let's add 1 to both sides. Let's divide both sides by 3. Remember, we're trying to get that x by itself. And at any point here, you can, of course, put everything on the other side. It's just like a seesaw. They can all sit on the other side. Now we've got to take the square root of this side to get x plus 1. I'm going to write it on this side this time. And over here, I need to remember to do plus and minus 1 over root 3. Now I can write it like that, or I can break the surd up. Remember, this is the same thing as the square root of 1 over the square root of 3. But of course, the square root of 1 is just 1. So the tidiest way of writing this is probably just to write 1 over root 3. But don't forget, this has got many disguises. You could always rationalize the denominator here and say that it's root 3 over 3. Either is fine. You're not necessarily expected to rationalize denominators in this sort of situation. Now to get the x by itself, we've just got to subtract 1. So we've got -1 plus and minus 1 over root 3. Now, having a quick look at what that gives you when you type it into your calculator is quite handy. So just type it in once and then change for the sign. So we've got -1 plus 1 over root 3. And that gives me -0.42 something something something. So that's going to be round about here, and that sort of looks right, doesn't it? Okay, and it gives you just a rough idea where to put your labels. Now go back into your calculator, but just move your cursor along and change your plus to a minus so you don't have to put it all in again. And we've got -1.5 or so. It's just slightly over. Now, rather than label your graph with decimals that have been rounded off, label them with perfection, with something that's exact. I would label this as -1 minus 1 over root 3, and this one over here is -1 plus 1 over root 3. And again, there's lots of flexibility. You could make this into one fraction, you could rationalize the denominator. There's no need to really fiddle with it, but at least here I've got something that's exact, and I've put it in my calculator just so that I can graph it so that it's roughly correct. Now, if you hate dealing with surds, you would still get full marks if you've just rounded off your decimals there and you've put these answers straight in. I just think where you can keep things exact, it's kind of nice to do so.